Welcome to your very first video of the year. This is Unit 1 Linear Functions, and today's video is going to cover our first learning target, function notation and evaluation. The question we hope to answer by the end of this lesson is, how do you evaluate using the function notation? First off, let's remind ourselves what a function is. A function is a relationship that assigns exactly one output for each input. You can think of a function kind of like a vending machine. The money that you put into the vending machine is your input. The snack you get out is an output. There are limitations to that. Some vending machines don't take certain coins. Some vending machines take dollars or don't take dollars. And you can only get certain snacks out, right? You're not going to get a Pepsi out of a Coke machine. So functions work the same way, inputs and outputs. The important thing right now is that we have exactly one output. Exactly one output. That's the key right now. An example of a function would look like this table. We have x's that are inputs and y's are outputs. Now I know I said exactly one output, but remember it's for each input. For each input, do we get an output? We do. For -2 we get 6, for 3 we get 11, for 6 we get 15, and for 9 we also get 11. But that's okay. It's okay that we get 11 for both 3 and for 9. That's okay. All right, so there's exactly one output for an input. 3 outputs an 11. It doesn't output anything else. 9 outputs an 11. It doesn't output anything else. So we're okay. This is a function. Let's look at a non-example. This is a non-example table of a function that is not a function. Here we see that 1 outputs to a 6, but 1 also outputs to a 15. That means there's not exactly one output. There's not exactly one output for input 1. There are two outputs for input 1. That's why this is a non-example. So you can repeat outputs, you cannot repeat inputs. Function notation. Let's get into actually the core of our lesson. Function notation is f of x. That's right, that's how we say it. F of x. Of course, after the f of x, there's going to follow some kind of mathematical expression. Now, f is just like the name. It's the name of the function. The x is the variable in the rest of the equation. Now, we could change the f to another name like g of x. That just means that another equation, its name is g. It'd be function g, function f, and function g. But f of x is just another way to say y. They both mean output, okay? Both y and f of x both mean output. Okay, you will be given an x to plug in to whatever equation is in the problem. When they are telling you to plug a number into the x, it's going to look like this: f of 2 or g of -5. These are instructions telling you, hey, wherever the x is in the f function, put a 2. Or wherever the x is in the g function, put a -5. So let's try an example with those instructions. Find f of 2 and f of -3 for f of x equals 3x minus 2. So our function for this problem is f of x equals 3x minus 2. First, we're going to take a 2 and plug it into the x, right there. Now, it's going to say f of 2 is equal to 3 times 2 minus 2. We can go ahead and work that out and come out with f of 2 equals 6 minus 2 is 4. So f of x is 3x minus 2. F of 2 is equal to 4. To do f of negative 3, we use the same exact function, okay? Same function, f of x equals 3x minus 2. But now we're going to take a negative 3 and plug it into the x. So what is f of negative 3? It's 3 times negative 3 minus 2. F of negative 3, after we work out the math on the right side, would be negative 3 times 3 is negative 9. Negative 9 minus 2 would be negative 11. So for our function of f of x equals 3x minus 2, the f of 2 is equal to 4, but the f of negative 3 is equal to negative 11. So whenever they're writing a number in parentheses next to the f, these are instructions to plug the number into any of the x's in the actual equation. We can even plug in an expression into a function. It's not just about numbers plugging into functions. We can actually plug in extra information into the x. So we have this f of x equals negative 2 minus 7. And we want to replace the x in that function with a x plus 1. So f of x plus 1 is going to be equal to, now this is what's going to happen. Where the x was, I'm going to open it up into a blank spot with parentheses. See? Notice that this blank spot right here is in the exact same position as the x right here. Okay, I'm opening him up to receive something. Okay, what is he going to receive? He's going to receive this x plus 1. So right in here, I'm going to write down the x plus 1. All right, again, negative 2x minus 7 gets replaced with an x plus 1, negative 2x plus 1 minus 7. Parentheses are important. Okay, parentheses are really important right here. Okay, let's rewrite this side. And again, notice it says x plus 1 here. It doesn't say just x. It says x plus 1 here because that's what this instruction was telling me to plug in. Now we need to simplify this side. Okay, actually work this out. Remember that when you have a number in front of parentheses, you have to distribute and multiply. So we end up with negative 2 times x is negative 2x. Negative 2 times 1 is negative 2. And we still have minus 7 over here. We can subtract negative 2 and from 7, and we end up with negative 2x minus 9. And that would be our answer. So this right here, it would be our final answer. So notice the difference between what we started with. We started with a negative 2x minus 7. After doing the plug-in, we ended up with negative 2x minus 9. Now functions can get plugged into functions, and they get written down two ways, and these are called composite functions. So one way that you write a composite function is with multiple parentheses. So here's how you say the first one. You call this f of g of x. f of g of x. What it means is you're going to have to plug something into the x's for the g. Then whatever you get, you plug into the x's for the f. So work from the inside out. The second one is really saying the exact same thing. It's just written a little bit differently. It says f of g of x. Still, we would have to do our work for the g of x, and then our answer goes into the f's problem. So again, we work out whatever we have to for the g's problem, then that answer goes into the f's problem. Same thing for this notation here. We work out what goes into the g's function, then what that answer is goes into the f function. Here's an example of this happening. We're given two functions. The functions' names are f and g. F's function is equal to negative 2x minus 7. G's function is equal to x plus 4x. So my instructions here, and you have to read them carefully, is g of f of 3. We must work out the f of 3 first, so then we can work out the g function. Again, work from the inside out. So let's work out our f of 3 first. F of 3 is equal to, remember this says to plug the 3 into the f's x, which is right here next to the negative 2. So negative 2 times 3 minus 7. F of 3 is equal to negative 6 minus 7 would be negative 13. So now that I know that the f of 3 is equal to the negative 13, I need to plug that into the g's function, working from inside out. Plug the 3 into the f, get an answer. Plug that answer into the g's. The g's over here, x plus 4x. So now it's time to try to do g of negative 13. Again, we plug 3 into the f's function, get an answer, plug that answer into the g's function. So the g's function has two x's, so I'm going to have to plug in the negative 13 twice. So it gets plugged in right here for this x, plus, I'm going to put parentheses around that so I know I got plus, so I plugged it in, plus 4, parentheses, yeah, there's another x, so it also gets the negative 13. So g of negative 13 is going to be equal to, follow our operations, 4 times negative 13, 4 times negative 4 times negative 13 is equal to 52, negative 52 because of my negative sign, so negative 52. So my answer of g of negative 13 will be equal to negative 13 minus 52. So that would be negative 65. So there's my final answer. G of negative 13 is equal to negative 65. To recap this problem, the instructions were to take a 3, plug it into the x for the f's function, work it out. Then whatever that answer is, plug it into the g's function, here and here, and work that out. Here's an example that uses the other way to write a composite function. This one says f of 7. So I'm supposed to plug a 7 into the f function, get an answer, and plug that back into the f function again. So we only need one function, and that function's name is f. So we're going to plug a 7 into it, get an answer, and plug that answer right back into it again. So let's start off with f of 7. This is instructions to plug a 7 into the x's in the f's function. There's only one x right here, so I'm going to plug a 7 right there. 5 minus 4 times 7. F of 7 is equal to 7 times 4 minus 7. That's the same thing as 5 minus 28. So our answer is going to be negative 23. That's my answer. That's my answer for this first part, okay, f of 7. But it's of f also. So we're going to have to take that 23 that we got from working out the instructions right here, plug it back into the f's x. So this 23 needs to get plugged right back in here again. Five minus 4 times negative 23. So our answer for this would be 5 minus, do the multiply first. So 5 negative 4 times negative 23 is positive 92. And so our final answer for this problem is from 5 plus 92, and that's 97. So that pretty much covers our examples. We talked about what a function is, reviewed that a little bit. We also talked about what it means to evaluate, what the f of x really means to us, how to plug numbers into it, work it out, and then we learned about composite functions. Composite functions are functions plugged into functions, having to work out the plugging in for one step and then use that answer to plug in to another step. If you still have any questions, make sure that you write them down in your left column and be ready to share them out in class.